Okay, welcome to the fifth Space Sustainability Talk, which is organized by Sichtraum, the Security and Technology in Space Research Network. My name is Daniel Lambach. I'm a political scientist at the University of Frankfurt, and with me is my co-host Maximilian Bertomini from the University of Bochum. In our previous talks, we have spoken about the problem of space sustainability as such, about the politics and the legal issues surrounding it. And today we're going to look at a question that is both more specific and more fundamental at the same time. How can we measure space sustainability? This is a crucial aspect for basically all the other discussions we've had. We need a way of estimating sustainability to understand the shape of the problem and in order to create scenarios about the impact of specific policies or measures or programs. And for that, our guest today is Dr. Francesca Letizia. She's a space debris engineer at ESA's Space Debris Office, which is located at the European Space Operations Center in Darmstadt, Germany. So basically right around the corner from my office. She has a master's in aerospace engineering and a PhD in astronautics, I read, and she wrote her dissertation on modeling space debris evolution. She's also a very prolific author of research papers, so do have a look at her Google Scholar page. And after a brief stint in the private sector, she joined ESA about 4 years ago. And there, her main tasks include the assessment of compliance with space debris mitigation guidelines. And she's also working on metrics for how missions impact the space debris environment. So she will tell us a bit about her work in a second, and to all the guests, which we heartily invite to contribute to the discussion later. A bit of housekeeping. If you want to ask questions, you have several options. If you would like to ask your question basically in person, including a video feed, just write the number 1 into the chat. If you just want to ask the question via audio, write the number 2. Or if you'd prefer not to ask in person, just write the question in the chat itself, and then we will pick it up later. Right, that is all for me for the moment. Dr. Letizia, thank you very much for joining us today. We are greatly looking forward to your talk.
Thank you very much for your kind introduction. And I have a couple of slides, so if you will allow me, I will probably share my screen. And I hope you can see it. Okay, good. So let me start. Yes, so as you already mentioned in your introduction, we hear the topic of space sustainability more and more emerging, but it's really important to think how we can quantify these aspects of space activity. And so in this presentation, I would like to share some of the initiatives where my office, or the Space Debris Office of the European Space Agency, is involved in this attempt of put some numbers on what space sustainability means. And of course, to start, I want to mention as a first step the preparation of our yearly report on the status of the environment, so our environment report that gives an overview of this status of space activity in general, and in particular an assessment of the global level of adherence to space debris mitigation guidelines. And I put in the slide a link and a QR code from where the report can be downloaded. So this is publicly available for everyone. And we published the last version in May last year. And just to give you an idea of what can be found in the report, I just selected one plot, which is related in this case to the level of compliance to post-mission disposal guidelines for objects that are in non-naturally compliant orbits. And okay, if I take the pointer, let's see if it works. No, okay, then I use the mouse. Basically, what we see from this plot is that if we focus on the case of satellites, so payload in low Earth orbit, so this dark blue line here, we see that the level of compliance with existing guidelines is still relatively low at the moment. So we estimate that it is below, or let's say around 30% if we consider the latest data. And this class of objects that are represented here in this slide, so the payloads operating in LEO are a very important subset of the space population, as they represent roughly 60% of the mass in low Earth orbit, and so they can play a significant role in the development of the Kessler syndrome, as these objects tend to be massive. So this means that in case of fragmentation, they will generate a large number of fragments, but also because they are in high altitude. So if fragments are generated, they will stay in the environment for a long time. And in fact, if we perform a simulation, long-term simulation of the environment, and we extrapolate the current behavior, what we found, as we see in the plot here in the slide, is that our current behavior is not sustainable, in the sense that you will see this very rapid growth in the number of objects. And we can see how a more stable environment can be reached if we are on the level of 90% of compliance to the post-mission disposal guidelines. So if we compare this number to the number that we observe in this plot, then we understand how far we currently are from this target, and how an important shift in how we deal with these end-of-life operations is probably needed. And while the analysis of this compliance level are, let's say, an essential first step for analyzing the space activity, we also have to be aware that there are some aspects that are not fully captured simply by this analysis. And the first one that I mentioned here in the slide is that there is so a missing link at the moment between the current debris mitigation guidelines and what is the objective of sustainable space flight, which, if you use the definition in the UN LTS guidelines, is the ability of performing operations now and in the future. And so if we think of the plot that I had in the previous slide, this means that probably if we just look at the number of objects like I had in the previous slide, this may be just a partial representation of the situation, because actually the ability of performing operation may be very different if we consider how these objects are distributed, whether these objects are active or not active. And this is an element that, with the analysis that I've shown before, we don't fully capture. The second aspect is also the dynamics of the space environment. So this means, for example, that the launch traffic that we are witnessing in the current years is very different, for example, from the one that was used when the guidelines were prepared. And this is also something so that we should keep in mind. And finally, the last point is that the guidelines don't tell us how to be compliant. So there are different options, different possibilities, but not all these options are equivalent in terms of the impact on the environment. And here, yes, what do we mean with this impact on the environment? So for us at ESA, this translates into two main questions. And the first one is, how detrimental is emission to his neighbors, so the other operators, and also how likely is emission to contribute in the long term to the Kessler syndrome. And to try to answer these questions in a quantitative manner, what we developed is a so-called space debris index. And which, as you can see in the slide, is actually the simpler risk metric. So we try to look which is the probability that an object is involved in a fragmentation, and what would be the severity of this fragmentation. And in particular, we measure this severity by looking at the resulting increase in the collision probability for other operational satellites. And as you can see here in the slide, this risk metric can be connected to several aspects of emission. For example, where the emission is operating, but also its size, or the background population of debris object and other operational satellites. And once that you have such a metric, you can try to use it, for example, to answer the question that you see here in the slide in a quantitative manner. So, for example, what changes if you operate a constellation or an emission at different altitudes, or which is the impact of having or not having propulsion capabilities in terms of the risk, so the debris risk associated to the mission, or for example, which is the difference of using a passive disposal system, so like a sail, instead of more traditional approaches. And the next step that I present here is to go beyond the evaluation of single objects, but to try to look at all the objects that are in orbit. And we want to compute the risk associated to all the objects in orbit, to try to understand whether this is compatible with the stable evolution of the environment. So this is stable evolution of the environment, something that I already mentioned in the beginning when we were looking at the long-term simulations. And of course, here there is we are trying to create a link of how the environment behaves, let's say in the long term. And we want to see this ability of performing operations in space now in the future. So what is this definition of sustainable operation? And we look at this as a finite resource, and we want to think, how can we measure this, and how can we say, let's say, how far we are from this cap of capped resource. And the idea here is again to use this metric that we have seen before to see how each mission consume a part of this shared resource, while instead we will use the long-term simulation of the evolution of the environment to understand which is the capacity of the environment, so which is the number and the type of missions that are compatible with its stable evolution. And this is just the first part, let's say the definition and the quantification. But then, as I said, once that you have this definition, you can also think, how can you manage this capacity in an efficient way? And in the slide, you have a list of points that what's needed to have such a system in place, going from something to monitor the status of the environment, but also something, for example, to record which will be the planned missions, and etc. This list is actually even longer. And of course, we are not there yet. This is something that we have just started looking at and try to understand how we can go from, let's say, something that is very theoretical to a framework that could be also viable. And so while the work on this is still ongoing, we are also already looking at other ways that we can incentivize more responsible behaviors from operators. And one of the activities where we have been involved is the space sustainability rating that we have developed together together with other institutions that you see listed here in the slide. And the idea of this rating is not to create a new set of guidelines, but rather to recognize positive behaviors. So basically the operators that are compliant with guidelines, and also the operators that even implement better than required behaviors in their missions. And in practice, this is done by scoring a mission under several aspects, one of which is the debris index that you have seen in the previous slide. But there are also additional elements, going from how easy it is to detect, identify, and track your mission, or, for example, which data an operator is willing to share and with whom, or which standards have been applied during the design and the operation of the missions. And so all these elements together are combined in an indicator, and this will tell you basically which is the rating of the mission. And just recently, some month ago, almost exactly 1 month ago, we have announced also that we are concluding the design phase of this rating, and we have selected what will be the actual host institution of this rating, which will be the eSpace Center at the EPFL. So they will be actually let's say the institution that will carry over this again from this conceptual level that we have developed to a more operational and practical instrument in the future. So to conclude, we have seen how the quantification of space sustainability starts from the assessment of compliance with existing guidelines. Then we can go one step further and apply a risk metric to try to quantify which is the impact of emission on other operators, so what we have in mind more the short-term effect, but also in the long term on the whole environment. And we have also seen how we can go even one step further and just not look at single missions, but apply this risk metric also to assess the overall status of the environment and link this with long-term simulation to understand which is the available capacity of the environment. And finally, also we have seen how this risk metric approach can be integrated into a rating. And we hope that this rating can support the promotion of positive behaviors among operators. And this concludes my very quick overview, and I'm happy to take any question. Thank you.
Wow, thank you. That was a very interesting and very tightly focused presentation. We have a comment in the chat from Darshan Kawat, who chose option 3. I'm not quite sure which one that was, because number 1 was including video, number 2 was audio only, and number 3 was please write out your question. You can do one. Wonderful. So you should have your video and audio enabled in a second. And also, please introduce yourself briefly, if you will.
Hi, thank you so much for that awesome talk. I'm a professor at Arizona State University. My background's in aerospace engineering, and I'm trying to figure out ways to get back into doing space systems related engineering work. And one of the intersections that I've been thinking about has been around space system design and biomimicry. Really appreciate the remarks that you made. I have 3 questions. I know you might not be able to answer all of them, but I'll just ask all 3 of them and you can pick and choose whatever you want to answer. The first is, are there any studies on the atmospheric chemistry impacts of just payloads being burnt up in different parts of the atmosphere, like, and what that means or what that looks like as a function of increasing number of payloads being burned in the atmosphere? The second is whether the space sustainability index that you're designing is focused specifically on satellites and satellites on the Earth, and whether the rating sort of extends to, say, Mars or other gasless bodies like Europa. Lastly, to what extent does the compliance apply to missions by governments, and to what extent do they apply to the private space industry, or what are the intersections there?
Okay, yeah, I think I can try to answer all of 3 if it's not a problem.
Go ahead.
So, yeah, thank you. Okay, so on the first one, so I am aware there have been some studies on the impact of re-entering bodies in the atmosphere. I think, however, that it was mainly focused on the activities of rocket bodies, interacting with the atmosphere. So that's what I had in mind. This is not something where I have been personally involved. It's something that was supervised, let's say, by our Clean Space office at the European Space Agency. So if you are interested, I'm happy to give you, I mean, you can write to me by email. I can give you the context and the name of these 2 studies that I have in mind, where they looked at this interaction with the atmosphere. But as I said, I think it was more related to the launchers part. So on your part on satellites, I'm not sure I can give you much information. But yeah, and the only thing that so as I said, I was not personally involved in these studies, but I know that they have looked both at the short-term effect and the long-term effect of these activities, and they found that the impact was not large, of course. But then, as you said, this was done with certain assumptions in mind, and it was also highlighted how it's a preliminary assessment that for sure will need also more investigation. But as I said, I'm happy to give you the details for these two studies that were performed. And for the second question on the SSR, no, actually, at the moment, we are not considering any application that goes beyond the Earth environment. And I will tell you even more. If you have seen a bit what I had in the slides, you have seen that these modules are also very, very much focused. So we have an interpretation of sustainability that we are using in the rating that is very concentrated on the debris aspect, which we know that is one of the aspects, but it's not the only one, right?
Yeah, yeah.
But this is a choice, actually. So we have decided to do this simply because we thought that to start, this was a good and probably the most relevant point. But we don't exclude that maybe EPFL in the future evolution of the rating would like to enlarge the scope of the rating. But we thought that at this moment, because it's very complex actually to have operators on board, to find agreement on formulation, etc., we prefer to have a very well-defined scope for the rating. And for the third question, in our report, actually, we present statistics on compliance, distinguishing the type of operator. So if you go to the link that I had in the slide, you will see the statistics by type of mission. So if it's amateur, commercial, civil, or military. And you also will find other types of breakdown, for example, by mass, or if it's a constellation and non-constellation. So all this typology we cover then there, and you can have a look a bit of the numbers.
Great, thank you.
You're welcome.
Okay, great. I do have a question about one particular point you had in your presentation regarding the disposal rates. I noticed that the graph was by end of life years per mission. So the sort of the latest figures were for the late 2010s. So these should have been missions that were launched 15 or 20 years prior to that, if I read that correctly. So would you expect that the figures would be noticeably different for missions that are launched today?
Yeah, so in again, we have in the report we have also the figure by launch year, but of course it's a very skewed one, right? Because you know that yeah, still I think that the average duration of a mission, it would be more in the range of 8-10 years. So we will not have a full representation of what is the current situation now. We have seen an improving trend, is if it is a bit what you were hinting at. As of course, we are aware that many of the missions that has been disposed so far were also designed before some of the guidelines were issued, or let's say, yeah, it's clear that the approach to space debris mitigation is changing, has been changing significantly in this last year. So we definitely hope that that this will change in the future. Of course, there is also another important change that we have to be aware, is that I mentioned that I was showing the slides the plot for the objects that are operating in non-naturally compliant orbits, and these represented historically a significant proportion. Now, of course, with the arrival of also large constellations that are operating at lower altitudes, of course, also this balance is shifting. So now we have more operators that by design, they decide to operate in lower orbit, also to, let's say, as a way to be compliant with the mitigation guidelines. So these also will not appear in the plot that I was showing you before. But again, sorry, I just want to say that in the report, you really have the full picture of how these different classes are evolving over time.
Yeah, the question of compliance is, of course, a very, very big one for me as a political scientist, and I guess also for Maximilian as a legal scholar. My impression, I mean, you did sort of mention in passing this 90% post-mission disposal rate as sort of the figure that would at least sustain current use of the orbits. Do you think that's achievable with the current state of sort of soft law mitigation guidelines? Do you think enough operators would subscribe to these guidelines to make this a realistic target?
So, okay, maybe I start from this. So if you look at the values for GEO, so not for LEO, what we see is that the value of compliance, level of compliance has been, let's say, very high and above 80% consistently in the last years. And the reason why this happens is that because it's clear that the operators have a strong commercial interest in having the georing clear from defunct satellites that could impact the operation of their valuable mission. So in that case of GEO, on top, let's say, of this soft policy that you mentioned, then there is also a strong commercial interest that acts very efficiently as a driver. And this is also something that we may want to keep in mind, because in the case of constellations, we may have also in LEO that they will have really an interest in keeping at least, let's say, their shell very clean from defunct objects. On top of this, in the same plot that I had before, we also saw, but I didn't stop of them, the trend or the evolution of the trend for the rocket bodies. And for the rocket bodies, what we see is that in the last 20 years, we went from 20% disposal rate to successful disposal rate up to 80%. I think we have in the last edition of the report. So in this for this subclass of objects, we really saw the shift that I was mentioning. And what we saw also in this last year is that more and more of these launches have been disposed with a controlled re-entry. So not even 25 years, but really a very active, it's a very quick disposal approach. So there are, let's say, these are all good signs that we can see in this way. And of course, it's let's say I'm not sure if I can tell you that this is enough or not, or if, especially from the policy point of view, because also we know that this target of the 90% is always a moving target. So with the arrival of the constellation, actually, we know that even better performance will be required for to have a stable environment. So that's also the difficulty probably in approaching this specific subject.
Mm-hmm. Yeah, great point about the rocket body sort of compliance rate. It would be interesting to look at whether sort of the norm evolution regarding disposal of rocket bodies sort of preceded other kinds of mitigation guidelines for satellites, but I think this will take us a little too far. Darshan has indicated that he has a few more engineering related questions, I suspect.
So I said I don't want to monopolize any of your time, but since the opportunity is there, I'll go ahead and ask another question. And I'm not sure if I have a very specific question, but it's just some general thoughts that I have, and I just want your response. And I guess this comes from my environmental ethic. You know, as somebody who values and respects nature, I'm wondering about your general thoughts or musings on the extent to which the way in which we think about space, the preservation of the sanctity of space, is affected by sort of antiquated frameworks of what environmentalism actually means. like, I don't know, just one question that comes to mind is, just because we want to search for life on Europa or Mars, what right does that give us to trash Mars, for example? And I'm just wondering, like, how an ethic of reverence for space or care for space can or cannot translate into the way in which we explore space, and to what extent are sort of the legal frameworks that currently exist based off of the way in which we conceptualize sustainability and environmental protection, that is just an old way of thinking about things. You know what I mean? I'm not sure if that's like a specific question, but it's like, I just kind of feel like badly in my heart that we might, you know, just ruin, quote unquote, these like sacred objects, but I consider them sacred. Other people might not, right?
Mhm.
So just some general thoughts, questions, musing, and I'm curious to know what you think.
Yeah. So I will start from this. I introduced the concept on the environment capacity, saying that for us, we see the ability of performing operations in space as a limited resource, limited shared resource. However, I'm also aware that this is not a view or point of view that is shared from anyone. I mean, from not anyone. It's not shared by everyone. Sorry, in the sense that maybe there are countries or operators that have a different approach to space, and they don't see not even the ability of performing operation as a limited shared resource. So this is already something where I don't know. So as I'm an engineer, maybe I'm not the best person to answer this question, but I think that already there, maybe there are some also cultural elements that could play a role in how we approach not even exploration, but also just, let's say, the fact that we keep clean and we don't let's say pollute around Earth. What I think it's important, or at least what we saw that is very important to create a link when we talk about these topics, is really the topic of sustainability in broader terms. And what I mean with this is that if you think about all the research that is done on sustainability on Earth, so I'm just talking now on Earth, many of the data, much of the data that is used for this analysis really come from space. And maybe you all know already that some of these elements can only be acquired from space. So there is this connection, let's say, that is very important between what is a sustainable approach to life on Earth means, and how this translates also to our operation in outer space.
Yeah.
And specifically, for example, for the case of the low Earth orbit or the geostationary ring, these, they are called protected regions in our sector. And the idea is that they are protected because we recognize that they are unique, and that also in the future we will need them, and we need to operate there like we do now. So I don't know if this is a very narrow, let's say, definition or approach to sustainability with respect to the framework that you were mentioning before, but I think it's already enough in the sense that we are already, at the moment, we are not there yet. So already with the guidelines that we have now, we are not even compliant to that, even if many people share that there is this need for action. So I think that for sure the sustainability is a very complex word to define, and can mean very different things across culture or across also sectors. But I personally really appreciate the definition that comes from the UN in the long-term sustainability guidelines, because exactly as I mentioned in the presentation, by creating, so it stressed the fact on the ability of operating in space. So it really puts the effort on our our also use, and the fact that it's not only for us, but also the future generation should be able to get from space the same benefits that we are getting now. So for me, this definition is a workable one, also from an engineering point of view. So this is what I appreciate in this. But yeah.
Thank you.
You're welcome.
Thank you. For the other listeners, if you want to ask a question, write the number 1 into the chat for a video question, the number 2 for an audio question, or just type it out. Right. Otherwise, I have a question again for Francesca regarding the space sustainability rating. I think that's a very interesting intervention into sort of the politics of it. And that's a really interesting consortium you're part of there with ESA, the World Economic Forum, researchers from MIT and UT Austin, and from Bryce Tech, a private sector company, if I got that right. And I mean, how do you envision this going forward? I mean, the methodology is there, and you do have a wealth of knowledge and sort of a certain legitimacy to draw on. But how will this? How do you envision this to have an impact practically? I mean, do you have space agencies sort of on board saying, yeah, this label that you can give out matters to them? Do you have legislators saying, yeah, this is a good idea to move forward like that?
So we don't have at the moment. We don't have this. I will be honest with this with you. But it's true that we had a lot of interest, and we are witnessing an increasing interest. So when I mean interest, what I mean specifically is that, for example, in the case of regulators that you mentioned, so we don't have any commitment, of course, but we have interest in understanding the concepts. So which this for me is already something good from our perspective, because we want to show that this quantitative approach, but also this where there is accountability and there is also transparency. This is how we are trying to build this rating. Could work also for space. I mean, let's also be honest. This is that we are doing with the rating is nothing that it's really new. If we look at what things that are done in other sectors, we always make the comparison with LEED, for example, for the buildings. For example, in the US, where we know the energy label, I had it already also in my slide. There are plenty of these ratings that are available in other sectors, and so I think there is something to be learned also from, as I was saying before, because sustainability is a much broader topic, and I'm sure that also from the space sector we can learn from others. And in practice, also what we see for the rating is that now for this year 2021, we will continue a phase of handover between the project team and the new host institution, where, as you probably heard, we had already in the past, already from last year actually, started a phase with some beta testers, so commercial companies that were nice to share the data with us so that we can perform some preliminary ratings. And we see that we see a lot of interest, for example, coming from other commercial entities to have this kind of rating, to understand how it works, which are the parameters that they will be taken into account, but also to understand how they can improve the rating of their mission. So how can a mission make more sustainable? So already just this process of creating awareness of what are the choices, what are the options that one can act on, I think it's a valuable one. And also there is a geographical component that we should not forget, because we are also trying to not look only at the let's say the large established players in the field, but also to look at emerging actors in space. And this is also why we decide to stress this element on recognizing positive behaviors instead of having something where you name and shame the bad operator, because we think that by recognizing these positive behaviors, you can also almost build a catalog of things that worked, let's say, they could be inspiration also for newcomers. So, and this is really a dialogue that is proceeding quite well. And I think that EPFL also will be in a very good position to continue this dialogue, in the sense that they come from an academic background, so they are in a good situation to continue this dialogue, both with the commercial counterparts, but also with, for example, emerging nations. So I think it's still ongoing, of course, but so far we have seen that there is a positive response.
If I may press on that point, since you draw the comparison with ratings and labels in other sectors, these seem to be especially successful when non-compliant actors are either subjected to the public spotlight, let's say, or public scrutiny, or if there's some kind of regulatory pressure on stakeholders to adopt these or to comply with these ratings. So the comparisons would be like sustainable fisheries ratings, which work through consumer pressure, probably not something that applies to the space sector. But you could look at examples like the ISO standards or something like that. So, but how do you get this kind of regulatory pressure on actors?
Yes, so I'm not sure if the rating will be the let's say the way of doing this, in the sense that, as I said, we are not trying to create new guidelines, but we want to recognize if you comply with them. And for example, the application of ISO standards, for example, or the application of standards for the operational products of your mission, or application of standard in the design of the shielding, etc. So all these are all things that are part of the rating. So of course, there are also other, let's say, initiatives where, as ESA, we are involved. As, for example, I remind the IADC, there is ISO, and we always play our roles also there to try to, let's say, be sure that there is a common understanding on what is needed to be done. But as I said, so I'm not sure if the rating, it would be now immediately something that will be endorsed by regulator. For sure, there are many elements that could be aligned, for example, in a license application process. As you probably have seen, many of the questions that we have, or the modules that we are trying to evaluate in the rating, are not very far from what an operator will have to submit during a license application. So we are not asking anything more than you would have in a space debris mitigation plan, let's say. And so this makes this, let's say, link between the two possible. But as I said, as you said also, I mean, we have to see what will be the willingness of to go in this direction. And at the moment, I see ourselves as we are trying to develop a tool and make it available. And we will try to support efforts in going this direction, but we are also not ourselves the regulators that can force this on to be applied. So yeah, that's our role, technical enablers. That's
Yeah, but great point about how this tool can be sort of used to create a link between regulation and the practices that the industry is supposed to be following anyway. Incidentally, next week we will talk with Eric Pellander from BHO Legal, who will talk about procurement, which would be one area where exactly this could be applied. Now, I do have a final question. I want to ask Maximilian first if he has anything he would like to discuss.
Well, not necessarily, because I feel that Francesca has picked up in her answers to the questions by Professor Coward and also to yours on a lot of issues that crossed my mind as well. So what I would like to do instead is thank you, first of all, for this very insightful comment and presentation as well. I certainly learned a lot, especially coming from a more legal and less of a technical perspective on space sustainability. And I very much appreciate your points on recognizing the approach to quantifying sustainability as of now as a very functional approach, I guess. And if I recall the series so far, I think we've seen that there is quite a number of ways to perceive sustainability, also in terms of including normative criteria like inclusion, but maybe also as Professor Coward and also I think Professor Schildknecht from last week has mentioned, recognizing a sort of inherent value of outer space as part of the environment. I think Professor Schildknecht mentioned the view into the stars as something that humanity has enjoyed over the time of its existence. So there might be very many factors that might be factored in eventually in terms of quantifying sustainability, although that might be very tricky from a technical perspective. But maybe what I would be very interested in is the idea of incentivization that you mentioned. And maybe as a quick question, I'm wondering whether or not the rating or the sustainability rating itself would already be the incentive that we're talking about, or is there anything more that you would think of as an incentive, and would that something differ in terms of whether governmental agencies are concerned or private actors, or is the incentive the same in both cases?
Mm-hmm. So on one end, I mean, of course, we are aware that the rating itself could be an incentive in the sense of the bigger picture of corporate responsibility. So if you frame it in this way, I think you could see it as a badge of honor in a, let's say, in a moment where you, let's say it in this way, you have an ongoing race also in saying who is the most sustainable one in space. So you have a lot of emerging companies or operators that stress how sustainable they are and how they have taken into account several aspects in the design of their missions. So to have these statements, let's say, certified or rated with this space sustainability rating, I think it would make them at least be sure that we are all speaking the same language. That's basically the purpose of the rating. On the other hand, we don't exclude that the rating could be used also for in other use cases. Like, for example, something that we have discussed is in the insurance market. So we had exchanges also in the design and in some workshops that we have organized also with insurance operating in the space sector. And you may think that this could be something that they could take into account. And to go back to the point that was made before on the procurement, something else that came to my mind is that what we are doing now when we evaluate emission is that also we would take into account how sustainable is the operation also of the launcher that you have used. For example, because you may have situations where I don't know, you are a small mission, small satellites that you're just piggybacking, and then even if your satellite in itself does not pose much risk to the environment, then maybe the launcher that is used is left in orbit and at a very high altitude, and this actually is a risk. And how do you incentivize that also these players go actually and try, if it's possible, to go for more the rocket bodies that instead are disposed and not left in orbit. So we see that also that could be something that maybe we could at least highlight and put as I said, is again a matter of awareness, because maybe not all actors have the same level of awareness of all the components of the missions that can play a role. So I think, yeah, these are a bit the what we had in mind so far. So yes, to reply your question, yes, it's on itself, but also can be used as a tool for in other parts of the space sector.
Great. I have one final question that is sort of a big picture one. When we spoke to Professor Schildknecht last week, he said, well, there have been significant improvements in terms of space sustainability practices over the last 10 years, but the scale of the problem has been intensifying so much that it's sort of running away from our efforts to contain it. Now, my question is whether you would agree with this assessment or whether you would see a different picture, and where you see sort of the biggest problems or the things we should be paying more attention to right now.
Mm-hmm. So, I mean, this is something that I mentioned also before, right? So when we set this 90% target, this was defined with a very different picture of how space activity will look from what is now. And actually, we are currently working on a paper for the upcoming IAC, where exactly we want to try to quantify also this exact aspect that you just mentioned. So how this target is shifting over time, let's say. And for sure, it's what already the IADC, for example, has highlighted in the past is that for example, for large constellation, we need a level of compliance that is very, very, very much higher than what we see now. And as I said, so we really need a radical shift in the approach to disposal. And for me, this is really the first and most important point, probably, because the importance is that we should look at the disposal not just as nice to have that comes at the end of the mission if it's possible and I could not really extend the mission a bit longer, but it should be seen as from the beginning as something intrinsic in the design of a mission, almost with the approach, let's say ideal approach of leaving no traces on the environment. Let's say we are aware that this is a big constraint on missions, so we of course we will have to find a compromise, but the target should always be how, let's say, I use this shared resource in an efficient way and I make it available again to others that they may be needed. So as I said, so by looking at the compliance level that we have now and looking at how the traffic is changing, or has changed actually in these last years, for sure I tell you that this is where we really have to improve, and it will really be important for the future of space operations.
Wow, well, that sounds like we're in a pretty critical period at the moment. Right. Thank you, Dr. Letizia. This has been a really interesting talk. And thank you to the audience for sticking with us. I hope you'll join us again next week in the 6th and final space sustainability talk, where, as I said, we will have Erik Pellander as our guest, and we will talk about legal tools to ensure sustainability. Again, thanks everyone for participating. Take care, and I hope to see you all again next week.
Thank you.
Thank you. Bye.
Thank you again, Francesca. I thought